Okay, welcome everybody after this coffee break. Let's proceed with the next session that's about sensor technologies in water treatment and water distribution. And this will be chaired by Harry Timmer, and Harry Timmer is researcher at Oasen, a drinking water company in the center of the Netherlands. Harry, the floor is yours.
Well, thank you, Jan-Peter. This session is about sensor techniques and online monitoring of various objects. I think it's a very interesting subject because as an end user, as a water supply company, we're always very curious on why can't we measure all these things online? But the technique is not that much evolved that we can measure everything online. But I think we're going ahead step by step, and today we'll see some of the new inventions on this terrain. The first speaker is Ms. Petra Ros of the Technical University, and I read that she was working with Arcades since 1 month. And she will start with presentation about the online monitoring of groundwater, I think. And Petra, it's yours.
Yes, so good morning everybody. Indeed, I will talk about online monitoring and control of groundwater treatment plants. This is a joint project with quite a lot of partners. The major partner is Vitens, DHV, Logisticon and Perceptive Engineering. And as you can see, there are quite a lot of people working on this project of the number of co-authors that are listed. So first I will start with a small introduction. The drinking water treatment plants are monitored and controlled by SCADA systems, and most of the time these SCADA systems mainly focus on water quantity. And of course it's important that enough water is going through all the processes, but it's also nice to know a little bit more about the water quality of your treatment processes. So therefore it's very important to get to know more information about your water quality. So to be able to optimize based on this water quality, the water treatment plants are monitored. This is done by laboratory measurements, but the drawback of this is that people take a sample and then that's been sent to the laboratory, and by the time you get the analysis back, sometimes it can take up to even a couple of days. Sometimes the people already consumed the water. So that results in a delayed water quality check. But in order to prevent that the water is also always of a sustainable quality, the treatments are very robust to make sure that the water the people drink is very safe. Another option is to use online measurements. But of course it's not very feasible to equip your whole treatment plant with a lot of online monitors because that's a very costly activity. So what are the means to be able to get more information about your water quality and to be able to control your treatment plant on this? Well, one of the things we think is a very good systematic is the development of self-sensors. So how can we develop these soft sensors? Well, we can develop them based on black box modeling. This is mainly data-driven modeling. So what you do is you collect a lot of data in the time, and based on that you make a model. This is an empirical-based model. Another option is gray box modeling. This is a little bit a combination between black box modeling and some real information about the system, the actual physical, chemical characteristics of the system. And another option is white box modeling. In this, you describe the actual processes taking place. But also this takes quite a long time to be able to develop these models and to be able to understand the processes taking place fully. And this is done based on mathematical equations that are numerically solved. So in this project, the objective is that we want to develop and implement soft sensors for, in this example, I will talk about the raw water intake of a groundwater treatment plant. This raw water intake makes sure that this sets your water quality that determines how your treatment process should work to be able to meet the required drinking water quality. So where have we done this? We done this research at pumping station Old Bade. This is situated in the Netherlands. This is one of the pumping stations of Vitens, and it's in the northern part of the Netherlands. It's a groundwater treatment plant where water is abstracted, aerated, rapid sand filtration is taking place, pellet softening, again rapid sand filtration and ion exchange removal. But during this talk I will mainly focus on the 17 abstraction wells that are present at the site. So which models do we have available? We have black box modeling tool developed by Perceptive Engineering, and it's called Architect MV. And we have a white box modeling tool, which is called Simela, which was developed by DHV and Delft University of Technology. So we have the data-driven modeling, and we have the white box modeling. So which platforms are already available at the drinking water treatment plant? So what we have is we have SCADA. There are all process data are available. And these are collected through a process automation interface into the real-time plant management system. In this system, every pump setting, every valve position has a unique tag. So this gives us information about the operation of the treatment plant. Furthermore, we have the laboratory analysis. So this is the LIMS system. These analyses are also coupled to the RTPM database. So in this database, we get a lot of information from the treatment plant. But we still want some more information about the actual water quality throughout the treatment plant. So to be able to do that, we are now in experimental phase where we have the so-called SLIM boxes. SLIM stands for Self-Learning Integrated Model-Based Management. This is the project, it's called SLIM. And what we do is that we have the unique opportunity to have a lot of online monitors. And of course, you will never see this in the full-scale system of all treatment plants, that they continuously have this running. But for this project, we have now, for the coming 2 years, we have these online monitors, and the processes we are monitoring are mainly processes that are taking place in a treatment plant. So we have redox, pH, conductivity, total hardness, bicarbonate, calcium, iron, and manganese. And what we're doing right now is that we're monitoring the treatment processes individually in time, and then with that information gathered, we're going to calibrate the models on. And based on those models, we can develop the soft sensors. So how does it look like? Well, this is a little bit a complicated scheme, but what you can see is that we have the plant data, so the real-time data coming in, and those data are being checked by black box modeling to see whether there are any irregularities in there. Then they're being sent to our white box models, and with those white box models we're going to calculate what the expected water quality will be after the process. Then we check that with the measurements that are on site right now, so the SLIM boxes, and then we see if there is any differentiation between what we calculated and what is actually being measured. Those differences we try to tackle by recalibrating the model, and then also we try to improve it even further by using black box modeling. And this all information is then combined and sent back to a dashboard, because in the end the water treatment companies don't really care about this system. The only thing they want to see is what is my water quality, where can I rely on. So what we think is also very important is that we want to develop a dashboard in which the operator can see what the quality is, how the state of the process is in. So, if we go to some preliminary results and discussions. If we, for instance, look at water quantity. Well, this can be, you can determine the water quantity based on the output of the pump, so you know whether it's switched on or off, you know the flow of the pump, so you can calculate the total flow. Besides that, there's also a flow measurement at place in the intake of the water treatment plant. So you would expect that both signals are the same. However, if you look at this graph, you see the raw water flow, in which the red line indicates the monitored flow, and the black dotted line indicates the calculated flow. So based on the amount of pumps that are switched off and known flow per pump or per well. And you see that this is a period of 1 month. And what you see is that in some situations, there is actually a difference between the measured flow and the calculated flow. So this can either mean my flow measurement is wrong, or my pump isn't giving, or my well isn't giving the amount of flow you would expect it to be. But it is an indication that something is deviating. And you can also see that at the end of the period, the calculated flow and the monitored flow are exactly in line, so that then everything is back to normal again. This is only for a short period I highlighted here. If we look at, for instance, the last 1 year and a half, you can see that most of the situation is that they're just exactly alike. So it's not something to worry about too much, but it's just to give you an indication that in this way you can pick up deviations. And then if we look at the water quality of each well, you see here there are a total 70 well numbers, and you see the iron concentration per well. And you can see that there is quite some deviation between the different wells, individual wells. So this also has an effect of when you switch wells on and off, whether they, what your water quality, your incoming water quality would be. So if your iron concentration varies, this also has an effect of your subsequent treatment processes to try to remove this iron. So this, if you know this information, and based on this information, you know which wells are switched on and off, you can calculate, for instance, with white box modeling, to see what your mixed quality would be. And with this mixed quality, if you know this already, you can get a different treatment strategy based on that. So what you see in this graph, you see 3 graphs. On the top you see the bicarbonate concentration, in the middle the iron concentration, and this is of the mixed water quality, and you see the pH. And you see this in time for almost 2 months, 1 month and a half, and you see quite some variation happening. The blue line indicates our predicted calculation based on which well has been switched on and the water quality per well. And you can see that there is some variation based on the well switching on and off, and the red dot indicates a laboratory sample that was taken in this period. This was the only laboratory sample of the raw water that was taken in that period. And you can see that at that period, the laboratory sample indicates a completely different quality than you would expect based on the changing of the wells. So if you only look at that single measurement and you base your strategy on that for the next coming 2 months, then you're quite off with your water quality predictions. So this means that it's important to get to know a little bit more of your system in time and not only say grab samples once in every while. So, and then of course we would like to implement this, because the end goal is that the operator sees what's happening. So what we're doing, what we're trying to do is implement this based on a dashboard system. So what you can see, for instance, here you have the 17 wells, and the green indicates, for instance, that a well switched on or off. And then besides that, you can say, okay, my water quality is, for instance, for pH, is this has been measured, that's been modeled, and this is what we expect it to be. And we can give an information about the stage your process is in. So in this way you get much more information of your treatment process, and this helps you to optimize your treatment process. So I think this small example of just the intake wells already gives you quite a good indication of what we're planning to do in the future throughout the whole treatment train. So that brings me to my conclusions. Is, well, the implementation of soft sensors, so online monitoring based on water quality modeling and online monitors, gives you quite a lot of information of the processes taking place. And also by implementing this visually on a dashboard, this gives you much more information and helps you to get a more stable operation of the treatment plant. So next step, what we will do, because this project is going on for still 1.5 years, is that to develop and incorporate these soft sensors throughout the whole treatment plant, and that at the end of the period we don't need as many online monitors to be able to tell something about the state your treatment process is in. Thank you.
Thank you, Petra. I forgot to say that Petra is doing a PhD study and on this topic, the modeling and the trying to improve the performance of the water treatment plants. In the paper, she said she will end this spring, I think, this year. Okay.